All right, I think it's time to get started. Please let me know if you cannot see my screen. I'll be sharing for just a moment, and then we'll get into the intricate details of Prometheus and Kubernetes observability. Thank you, everyone, for making time today. As I touched on, today's session is all about cluster observability and a bit of a focus on Prometheus, but as always, these sessions are for you, our attendees. So if you have questions, please do ask. More on this session, as always, we run these sessions every 2 weeks, and they are for the Kubernetes community to join and ask questions. Hosted, obviously, by Platform 9. We have a SaaS-managed Kubernetes platform that connects to AWS, Azure, and Google. You can either build clusters that we call native clusters in those environments, or on-premises on VMs or physical servers. We also have the ability to bring in and help manage EKS, AKS, and GKE clusters. If you want to interact with us during this session, please feel free to ask questions in the chat or the Q&A. There's also a Slack channel that's on slack.platform9.io, and you can jump into the AMA session there. If you're brave and want to ask a question over the airwaves, you can use the Zoom raise hand session button, and we will unmute you and we can have a live chat. If you do that, we do try to keep the questions limited so we make sure we have enough time to cover everyone's questions. Today's session is hosted by myself, Chris Jones. I'm a group product manager here, as well as Mayuresh, who's one of our lead engineers and has built our add-on operator and helps manage all of the add-on applications that we take ownership of as Platform 9 and do lifecycle, the deployment, upgrades, break fix, all of that goodness. So a bit of an expert in the field of operators, as well as what we're going to get into today, our monitoring deployment that is made up of Prometheus, alertmanager, Grafana. And today we're going to sort of get into the details of how we do what we do and how to make great use of our monitoring deployment within your Kubernetes clusters. So with that, I'm going to click stop share, and I'll hand over to Mayuresh. He can introduce himself, and then we will get started. As always, if you have questions, please ask. The better the questions, I think the better the response we will have. All right. Over to you, Mayuresh.
Hey everyone, this is Mayuresh, and I'm a developer at Platform 9. And we have been working on implementing a Prometheus monitoring stack on PMK for a while. And we would like to share our learnings with you. So this is the agenda for today. We'll start with a very basic question. What is Prometheus and how it fits into in any existing observability model? Then we'll move on to a Prometheus operator and if it is even needed in a given situation. If the answer to that question is yes, then what are the different operator objects that are relevant here to this discussion, and how do we configure them? So we'll take a deep dive into those things as well. Then we'll talk about Grafana, how to visualize all the metrics that we have collected. Finally, we'll then talk about the PMK monitoring stack. So as Chris mentioned, Platform 9 manages Kubernetes clusters for you, and we also deploy a monitoring stack on a cluster if you choose so. So this is a pre-configured monitoring stack ready to use, and I'll discuss in depth how we have managed to configure it and what we can learn from it. Finally, there will be a demo of how all of that looks like, and we'll also discuss if you want to do some of these things yourself, then what are the pitfalls and what are the things that you should be aware of. Also, note that observability in general is a huge topic, and there are a vast number of tools and ways to configure it. This is something that we have used, but once you are aware of one way of doing observability, other things make sense and they're easy to learn. So with that in mind, let's start with a very basic question. What is Prometheus? So Prometheus is an open source tool, and it helps you scrape metrics from n number of services that you might have. So let's say you have an environment and there are 10 services in your environment, and all of them you want to monitor. So let's say you expose a slash metrics endpoint on each one of those 10 services. And if you configure Prometheus correctly, Prometheus will invoke each one of those 10 services slash metrics endpoints every few seconds. It will collect those metrics and it will store them locally in a time series database. Having done that, Prometheus then will do two things. One, it will evaluate Prometheus rules. So let's say you have those bunch of services, all of them expose a bunch of metrics, and one of that metrics is CPU usage. And now you want to generate alerts if the CPU usage of a particular service goes beyond 60% for more than 5 minutes. So if the CPU usage of any one of my services goes beyond 60% for consistently for 5 minutes, I want the alert generated. So you can define those rules in Prometheus format, and Prometheus will evaluate these rules every few minutes. And if that rule evaluates to be true, then it will generate an alert and forward it to something called as an alert manager. So Prometheus and alert manager are part of the same GitHub project. So alert manager is used to accept alerts from Prometheus and then forward it to various locations that you might have configured. For example, you can configure alert manager to send out alerts to Slack, to emails, webhooks, VictorOps, and a bunch of other endpoints that alert manager configuration allows. The second thing that Prometheus does is it serves PromQL queries. So PromQL is Prometheus query language. And this is similar to the way a MySQL database serves MySQL queries. Prometheus will serve PromQL queries based off of the metrics that it has scraped from those n number of services. So once those queries are invoked, you can then get a sense of how a particular service has been behaving over a period of time. So using these PromQL queries, I can see over the past few days what has been my CPU utilization, and you can plot a graph. So typically this is done by Grafana, where Grafana talks to Prometheus, queries it using PromQL, and then shows it off, visualizes it in some Grafana dashboard. So that's how all of these various moving pieces, they fit together. And that is one way of deploying a monitoring stack. So we'll look into that. So let's start with something very simple, and then we will evolve this into a monitoring stack for Kubernetes. So let's say for Prometheus, you have a binary. So Prometheus is mostly written in Go, and you have a Golang binary, and you have a config file. And the config file looks like this. So again, this config file can get very complex, but let's start with a very simple example, and then we can evolve this. So you invoke Prometheus using this particular config file. What this means is the Prometheus binary is going to invoke localhost 9090/metrics every 15 seconds. So every 15 seconds, Prometheus will invoke this endpoint, get those metrics, and save them locally in a time series database. Now, if you do a curl to this particular endpoint, how does that look like? It looks something like this. So remember the earlier example of you have a bunch of services, all of them exposing metrics on /metrics endpoint. You can't just expose any metrics. It has to be in a particular format, and that format is the Prometheus metrics style of exposing metrics. So there are a bunch of libraries and APIs using which you can expose any metrics in this particular format. And there are primarily two types of metrics. One is a gauge, another is a counter. So a gauge is a particular metric value which will increase and decrease over a period of time. And a counter is something that most of the times it will keep on increasing over a period of time. So the amount of free space on a particular file system will keep on changing. And the network packets that you have received on a particular device will keep on increasing. So that's why gauge and a counter. You'll notice that the same metric can show up twice, and each of that metric can have a particular label. So in this case, you can have the same metric showing up twice with different devices, possibly different file system types, and so on. So when Grafana or any PromQL query is querying, these labels provide to be very useful. So let's say that you have a bunch of nodes in a particular cluster, and now you want to find out file system on a particular node, on a particular mount point, what is the free space. So using these labels, you can query and narrow down your search. PromQL, how does that look like? So let's say you want to get all Kubernetes events for a pod when that pod was evicted. So Kubernetes events are generated for a wide range of reasons. I want Kubernetes event for evicted and when it happens on a pod. So this is how you can query it using labels. Give me all persistent volume claims which are in a pending state, and this is how you can query it. Give me all the pods which are in failed or pending or unknown state, and sum it up by namespace and pod, and this is how you could query it. So that's the Prometheus, that's the PromQL way of querying. Notice that Prometheus allows a wide range of functions that you can work with. You can have absolute, sum, rate, irate, something similar to our typical SQL queries. So there are very interesting things that you can build up based on this. So now with this basic understanding, let's take a deeper look at the Prometheus config file. So earlier we saw that there was only a global section and scrape configs, but there are a few more sections. So the global section, it talks about the global variables, and you can define whatever is defined here applies for the entire thing, and each of these variables can be overridden in individual sections. We spoke of Prometheus rules. Remember the CPU usage going beyond a particular value, then generate an alert. All of those rules can go in a particular file, and that can be placed in a rules file section. What are the services that you want to scrape? That you can place in a scrape config section. I've taken a very simple example, but Prometheus supports a very wide range of ways of configuring services that it should go and scrape. So there are labels, regexes, and lot many things. I've just kept this very simple. Once a particular rule turns out to be true, where do you want to send that alert to? So alert manager section takes care of that. Prometheus also allows a remote write. So one Prometheus, whenever it collects a bunch of metrics, it can remote write to another Prometheus. So that's one more way of doing it. So as you can see, this can get pretty complex. And this is how a Prometheus config file would look like. Now with this understanding, we want to deploy Prometheus. We are not even at Kubernetes yet. Let's say you have a single node VM, you have a bunch of services running as systemctl services. You can just easily add the Prometheus binary and create a systemctl service around it and give it the right configuration file at the right path, and you're good to go. And that's how Prometheus will start scraping metrics off of whatever it is that you have configured. If you want to containerize it, you can do a Docker run, and you can mount a particular file at the correct point, and you can containerize Prometheus as well. Or the third option, if you want to go into Kubernetes, you can add Prometheus as a simple deployment. You can front it with a simple K8s service. The configuration file that we spoke of, you can put it in a config map and mount it at the appropriate location. The same thing you could do for alert manager as well, a deployment and a service, Grafana deployment and a service. Everything can go into this particular config file so that it scrapes from the right services, it delivers targets to Grafana. We can configure Grafana and we can mount the configuration file for Grafana, again with a config map, so that it gets metrics from Prometheus. And that's what you need. If your configuration file, if this is static in your case, if this is never going to change, you can just configure it once and that's about it. You never need to worry about anything more. If your configuration file is going to be static, then you don't even need a Prometheus operator. This is something that can easily work for you. However, more often than not, you might want to change the services that you want to scrape from. You might want to change the alerts to be delivered to a particular location or multiple locations for that matter. You might want to change the Prometheus rules that have been configured. So this change, if that is going to change, which will happen most of the times, in that case, it's much better to use a Prometheus operator. So I'm assuming some basic knowledge about operators. I'll just quickly run through it. So in Kubernetes, you can extend resources uh, with operators, with Kubernetes operators. So for example, you can create an object of kind deployment, and the API server and controller manager will end up creating a pod or a stateful set or whatever it is that you have configured. However, with operators, you can create an object of kind Prometheus, and in response to that, the Prometheus operator, this itself is a deployment, which is a running pod. You can create an object of kind Prometheus, and in response to that creation event, the operator can do something. So in this case, it is going to create a stateful set for Prometheus. It is also going to create a config map. It is going to mount the config map at the right point, and it will make sure that the Prometheus stateful set internally, which is a pod and a service running within, that runs fine. So this is a very basic idea of operators. Just a side note, if you are new to Kubernetes, if you're new to the idea of operators, then Prometheus operator is a good place to start. So as I said, you create an object here of kind Prometheus, a stateful set comes up, a config file is created, and all of this is taken care of with the Prometheus operator deployment. Then you create another object of kind Prometheus rules, and you define a bunch of rules there, and all of those rules, they end up in the config file. Who takes care of it? The Prometheus operator takes care of it, because it's watching the creation of all objects of kind Prometheus rules. Then you go ahead and you create an object of kind service monitor. And on the creation of this particular object, again, Prometheus operator takes note, and whatever it is that you have configured to scrape metrics from, those things are updated here. So service monitor defines what are the services, which are the services that I want to scrape metrics from, and how do I want to go about it. So let's take a deeper look into all these objects. So just to reiterate, Prometheus operator is a Kubernetes operator. These are custom resources that have been defined by the Prometheus operator. So you can create objects of kind Prometheus rules, service monitor, and a bunch of others, which I haven't included here. Okay, so this is how each of those YAMLs look like. So we create an object, kind Prometheus, a stateful set comes up, and we have a running Prometheus service. Now, if we want that particular Prometheus instance to scrape from all services in these two namespaces and all Kubernetes services who have these keys, so all Kubernetes services in these two namespaces, which have either a key app node exporter or app kubestate metrics, Prometheus should invoke /metrics on all of them. So that can be specified and configured using a service monitor object. You can create a Prometheus rules object, and you can specify all the list of rules that need to be evaluated by Prometheus. Now the question is, how does this object know that it is related to these two? So that happens through labels, where we say that for this particular Prometheus object, use a service monitor object which has these labels. And you will see that these two labels are present here in the service monitor. So that's how these two objects are now linked. Similarly, for Prometheus rules, we have a rule selector, and it says use all Prometheus rule objects which have these labels, and the same label appears here. That's how this and this one is linked. Again, note the idea of operators. These are just empty objects. The Prometheus operator pod is looking and watching all of these and then doing whatever is required. There is another object of an alert manager. And if you create this particular object, then a new stateful set for alert manager is created. Note that there is no label-based binding here, but in the Prometheus object, we are specifying that whenever an alert needs to be generated, please forward it to this particular service. So along with this particular object, we are fronting it with a Kubernetes service with this name, and that's how this and this gets associated. So this was a sense of how all of these objects interact with each other. Note that there can always be a many-to-many mapping. So we can have multiple Prometheus objects, and then there will be multiple Prometheus instances. And one object can map to multiple service monitors and vice versa. So this is a many-to-many mapping, and all of that is taken care of through labels. Now with this understanding, we can go back to the configuration file, and we can see that how each of these objects relate to each of these sections. So all the rules part is taken care of, is related to the Prometheus rules object. What and which services to configure and how to detect them is taken care of by the service monitor object. Where to send those alerts is taken care of by indirectly by alert manager object, but mostly through the service name. So this is how the operator works on the Prometheus config file. Just to recap, all that the Prometheus operator is doing is it's managing this particular config file for us. So as I said earlier, all of these things we could have done without the Prometheus operator. And this config file, if you are ready to edit the entire thing on your own, that's fine. No need for an operator. However, managing this can get very tedious very soon. And with an operator, it provides us a way of configuring all of these it gives us a way of configuring all of these objects in a human readable way. So you need not really edit and configure this tedious config file. You just need to edit the service monitor object saying, hey, add these labels, and that will take care of it. The operator will take care of it. So this is the reason why people use operators. It is to abstract away some of the complexity in a single place, and then you can derive most of these things partially or completely through custom resources. So that's the whole idea of using operators. Note that all of this is being done so that the configuration file is being handled correctly, and actual Prometheus configurations too can be done through the Prometheus object. So with this understanding, let's move on and let's go to the PMK monitoring stack. So as I said earlier, the PMK monitoring stack is deployed by Platform 9 whenever a cluster is created through Platform 9. And all of this is pre-configured. So let's talk about each of these one by one. So we have already seen the Prometheus operator. This is a deployment. Along with it, we deploy each of these objects. So the moment we create a Prometheus object, a stateful set comes up. We create an alert manager object, alert manager stateful set comes up. We create a service monitor with the way we saw earlier with labels. And that ensures that this Prometheus starts scraping from all the relevant services that we have configured in service monitor. We create Prometheus rules, and those rules are then part of the configuration file here. And whenever any of those rules come out to be true, an alert is generated and sent forwarded to the alert stateful set alert manager. Along with this, we also deploy Grafana. Grafana is a deployment. It's not part of the Prometheus operator. It's an external deployment. But within Grafana, we have made sure that it has been configured so that it retrieves metrics off of Prometheus, and we have added a bunch of dashboards. So all the metrics that we have scraped, a number of them can be visualized in different ways. And this is the link that is shown on the UI. Let's talk about each of these. So these are the places from which Prometheus is going to scrape metrics from. So you must have heard of node exporter and kubestate metrics. So there are a bunch of standard Prometheus exporters which export Prometheus metrics in a particular format. And node exporter gives you information for each of the nodes. So node exporter is a daemon set. Runs on every node, exposes /metrics, and Prometheus scrapes that data. Kubestate metrics is a deployment, gives information about Kubernetes cluster that it is running in, and that gets consumed by Prometheus. Kubernetes events exporter is a Platform 9 service that we have written, and it exports all of the Kubernetes events in Prometheus format. Now, this is quite useful because whenever a particular event is generated, it stays in the kube cluster for an hour, or maybe you can configure it for more, but typically it's an hour. And that very important information is lost. So we have added a service which reads those events and then exports it in Prometheus metrics format, and then Prometheus consumes it. so that we can visualize it using Grafana dashboards later on. It has also, Prometheus has also been configured to scrape metrics from Kubelet, CAdvisor, and API server. So these are not deployed as part of the stack, but Prometheus is configured in a way to scrape from these as well. So they also present a wealth of information that can prove to be useful. Again, note, just to reiterate, when this particular monitoring stack is deployed, all of this is pre-configured. The user doesn't really have to do anything. The moment all these things come up, they are already configured to talk to each other. And the moment Prometheus comes up, it starts scraping from all of these places. And through Grafana, these metrics can be visualized. At this point, the only thing that the user has to do is to configure the targets where those alerts need to be sent. So alert manager needs a secret to be configured where you need to specify where my alerts need to be sent. So it can be a Slack channel, webhook, email, Victor Ops, and a bunch of other things that alert manager allows. So that is something at this point that needs to be done manually. In the coming releases, we'll think about automating that as well. So with all of that, let's go into a demo.
Might also be a good point to see if anyone has any questions. I think we just covered a huge amount of Prometheus 101 in a very short amount of time. So whilst you pull that up, we'll throw it out there. See if anyone has any questions so far. I think one of the questions that came in earlier is, can this coexist with Sysdig? It can. They're sort of complementary to each other. Just looking at Prometheus as a monitoring tool, it's pretty common for people to deploy. If you can sort of package it using the operator and pre-configure the dashboards, what that allows you to do is bring up clusters that just have monitoring built in. And if you are using a paid for solution, but you're giving each of your, say, developers or DevOps team members access to clusters for themselves, if you just build in the Prometheus Grafana stack, they get monitoring, and it's open source, it's free, and you don't have to pay for that enterprise solution that you have implemented. So that's one reason to go for this. We include monitoring and the Grafana stack in each of the clusters that we manage for two reasons. One, to make sure that all clusters have monitoring, and if you are allowing your developers to build and have access to their own, it's just included. It's much simpler. And the second reason is to make sure that every cluster has a source of truth. So when you deploy a cluster, if you do have third-party monitoring or an existing enterprise monitoring stack, that you've got 2 points of data to compare and contrast to. And as Mayuresh was touching on, over the coming months, we will be making a number of enhancements to allow you to further customize our monitoring deployment and use things like remote write and set up alert manager receivers so you can start externalizing the events as well. With that, I'll hand back over to Mayuresh if there is no questions.
Okay, so let's say, so this is the platform line management plane. And let's say that how do we enable the monitoring stack on a cluster? So two ways of doing that. Either you are creating a cluster with bare OS hosts. Let's say I'm creating a single master node cluster. Give it a name. I give it Kubernetes version. And I select monitoring. This is checked by default. I select a master node. Select a bunch of worker nodes. I use the default networking options. And now if I click on complete, since Prometheus monitoring has been enabled, this will create a cluster on this bunch of nodes that I've selected. And once the cluster comes up and once it converges, the platform line management plane will detect that, and it will deploy a monitoring stack on the newly created cluster. Once that cluster comes up, and once all the pods in the monitoring stack are up and running, then a Grafana link will appear, and you can click on this and it's ready to use. Another option is for an existing cluster, you can select it, you can edit a cluster, again select the monitoring checkbox and enable it that way. So it's that easy to enable monitoring on a given cluster. So let's click on this and let's see what happens. So there are a large number of Kubernetes dashboards that we configured, and I've kept tabs open for each one of them. But when you click on it, the default cluster explorer Grafana dashboard will come up. So note that each of these dashboards, if you just deploy Grafana in a deployment, nothing will show up because there are no dashboards. And then using the UI, you might want to go and import dashboards and do something like that. However, in the monitoring stack, we have added a bunch of dashboards, and all of them are mounted as config maps. And they are mounted in the right place so that the moment the Grafana deployment comes up, all of these things are ready to use. Also, Grafana has been configured to talk with the Prometheus instance that we saw earlier. So directly it starts pulling information from there. So before we go into these, let's quickly take a look at the Prometheus instance itself. So I've opened this up on a node port, and the Prometheus instance that is running itself has a very basic native UI. I just wanted to show this to you because let's say if you are doing it yourself, then this UI is very useful for debugging, for finding out if whatever it is that you have configured as targets is working or not. Note we were talking about the service monitor object earlier, and depending on how we configure it, the Prometheus instance starts scraping targets. So right now it is scraping from all of these. It's scraping from an API server, C-Advisor, which is within Kubelet. So it is scraping from kubelets on all three nodes, C-Advisor from all three nodes, and the service monitor object, which has led it to scrape from the Kubernetes service, the Kubernetes events service, node exporter, which was a standard exporter, and kubestate metrics. So if you're doing all of this yourself, then this UI will be quite useful for debugging stuff. Also, we spoke of the Prometheus rules object, and we configure a large number of rules that can be used. And you'll notice all of these are PromQL queries. So let's say I want all, whenever my pods are being evicted, so whenever Kubernetes events metric is seen for a given pod with when it is evicted, and if that is happening for more than 5 minutes, then generate an alert. If my pod is in a failed state, in a failed create state for more than 5 minutes, generate an alert. Failed scheduling, when for whatever reason CPU is not enough, memory is not enough, and that happens for more than 5 minutes, generate an alert. So this way we have a large number of rules that are again pre-configured. Nothing needs to be done. The moment this tax comes up, this is useful. And the moment Prometheus sees that this is happening, right away it will fire an alert. PVC pending. I have created a PVC, remains in pending state, doesn't come out of it. Fire an alert, and so on. There is something called as recording rules. So as you notice, these Prometheus rules are evaluated every few seconds. Typically, it's 1 minute, the default interval. But you can calculate them. You can ask Prometheus to calculate them and keep those values so that they can be reused. And you can define that with recording rules. This is just to make sure that the computation happens quickly. You have a bunch of other rules. If my pod keeps on crashing for a long amount of time, then generate an alert. Pod is not ready for a while. If generation mismatch is seen, I've changed something, but it's not really moving in that. My deployment is not converging for a long time. Again, that's a source of concern.
Mayuresh, we have
Yes.
a question that came in, if you don't mind.
Sure.
you can have a look in chat if you'd like, but how easy is it to deploy a custom monitor like Ping Google, graph response time, and set up alert to console with value over 50 milliseconds? So just kind of wiring everything up in Prometheus, it sounds like.
Okay, so I'm trying to understand this. When you say deploy a custom monitor like Ping Google, do you mean we want a way of doing a bunch of things, and if it is not working, then create an alert? If that's what you mean, it doesn't very easily fit into this way of things. So this is more of looking at what is the state of a Kubernetes cluster, and something is odd, then I want to generate an alert. So as we saw, PVC is in pending state for more than 5 minutes, generate an alert. This example, I'm not really sure if it will fit in easily, because this looks like a bunch of things that we want to create, that we want to test it out. And if it is not happening within a given amount of time, then we want to generate an alert.
And would you say it's maybe not a great fit because Prometheus is more about scraping information, right? Going to an endpoint of something and scraping the information off of it versus going the other way of, sending a request to something.
Exactly.
Yeah, this is.
So Kenneth, if that helps out, please, re-ask the question if we can help out any more there.
Yeah, I think it's good to sort of touch on this. Prometheus is taking a slightly different approach to monitoring. Most monitoring systems, have agents, be it an agent that's on something or an agent that's remote or agentless, that'll actually do the data origination. So it's generating the data. Prometheus's approach is basically saying, I'm going to reach out and I'm going to pull data that's being exposed and originated from something. So if you wrote a Python script and you had Kubernetes run it on a job cycle or a cron job cycle that pinged Google, and you wrote a metrics endpoint, you could then configure Prometheus to scrape data from that every 5 seconds. And Prometheus would automatically put that in a time series database. You would then create a rule that says, if that exceeds X response times, send an alert.
Right. And just to answer the further question from Kenneth. So let's say you have a service, and that service is supposed to respond each of its REST queries in a given amount of time. Let's say that's a front-end service, that's a back-end service which is serving a couple of REST responses. You can expose a slash matrix on it, and there internally you could keep track of the response time that was taken for each of the services requests that came in from the UI. Expose that value on slash matrix. Make sure that Prometheus scrapes from slash matrix and maintains it internally. And then here we can define a rule saying that if the sum or the rate, so there are very interesting functions that Prometheus provides. If the sum or rate of the response time in this particular time slot is greater than this value, then generate an alert, because I never want my response times from my backend to be more than 500 milliseconds or something like that. So yeah, that's a way to generate an alert. Okay, moving on. As I was saying, there are a large number of Prometheus rules that we deploy, that we configure, and they are ready to use. So the moment something odd is seen on the cluster, alert will be generated. So this one is about when any of your nodes, the file system is running out of space. So it need not be a very simple rule. It can get as complex as you want. So anything that PromQL supports, and you can add it as a rule. My node file system is filling up. And interestingly, you can also have a for. So when this particular rule is true for this amount of time, then I want an alert to be generated. Okay, so by the way, with all of these things that we spoke of, how does the configuration file look like now? So it has a global section, it has a bunch of global variables, it has an alerting section and alert managers that we have configured. It has a rules part because we have configured the rule file, and scrape config since we have a bunch of targets to scrape from. This is how it looks. Now imagine doing all of this manually. So this gets quite complex quite soon. So always better to use a Prometheus operator in such a case. Okay, coming back to our Grafana dashboard. So as I said, there are a bunch of dashboards that we support. This one is the default one for Cluster Explorer. For Grafana, one thing to keep in mind, if you go to grafana.org, there are a large number of free open source Grafana dashboards that you can use. And you can always copy them. It's a JSON file, import it in Grafana. And more often than not, it is not going to work. Why? Because the metrics that they have assumed, each of these dashboard is a query, is a PromQL query. So CPU usage internally, it's firing a PromQL query to Prometheus and then showing it here as a graph. More often than not, those free open source dashboards have a particular value which doesn't work with the metrics that you have configured, some minor things here and there. And most of the times it's a bit of a painful experience to do that. So
Mayuresh, we've got another question here. Tejesh asks, is there something to do projections? An example, your disk space is growing at 5% per month. In 6 months, you will run out of disk. Any thoughts there?
I believe it's possible. I don't have an example at the top of my mind, but I think it's very much possible. As you saw those examples earlier of disk filling up, it was comparatively simpler as compared to what you are asking, that if it reaches this % of the total, then generate an alert. But I think what you are saying should also be possible. I would point you to these functions supported in PromQL called as rate, irate, sum. There are very interesting things that you can build up based on these querying functions.
Yeah, there's also a predict linear, which will give you a simple linear regression, I believe, of a metric.
Right.
On that topic, capacity forecasting is a bit of a complex beast. Linear regression is going to give you obviously a projection based on a constant rate of change. It's not going to be able to accommodate for an immediate shift or a change that was otherwise not in the historic pattern. So that is one drawback of just using that. But it'll get you started.
Right. Moving on to the next dashboard. So the next one is quite interesting. It is for CPU and memory usage. So this one, we didn't find anything similar to this. So this one we have created in-house. So this shows the total CPU and memory usage for the entire cluster. Then it shows the same thing by namespace. So within the cluster, each of my namespaces, what is the total CPU and memory utilization? Within a namespace, if I select one, what is the total CPU and memory utilization of all the pods in that namespace? And if I select a pod, within that pod, what is the total CPU and memory utilization of each container? So, and within the container itself, again, you can drill down to what is the type of memory that is being consumed, whether it's an RSS, cache, swap, and so on. And all of this is possible. You can select it here. Yeah. So here I've selected the namespace cube system. Within cube system, K8s master. And within the master pod, I have these 3 containers. So I can select any one of them, and I can drill down all the way down to a container and find out who is causing trouble. So we found that this was a very useful dashboard for querying resource usage. Another one that we created was Kubernetes events. So as I said earlier, Kubernetes events they have a wealth of information, but hardly any way of tracking them. So we export them as Prometheus metrics, and now you can track if an image pullback off, for example, has happened. So this event is generated in Kubernetes when you specify an incorrect image. Now, this event would have been lost in an hour typically, but since it is in Prometheus, you can go back and you can query for the last 7 days because our retention time is 7 days. You can go all the way back and find out, hey, give me all the events that have happened in the last 7 days. And you can see if a particular event is reoccurring, if a particular behavior is happening over and over again. You have liveness probe failing for a particular pod being unhealthy, a back off when a pod keeps on restarting, doesn't exit one, failed scheduling when you specify CPU memory numbers that are so high that it can't be scheduled anywhere, failed create when your pods are getting evicted, when eviction threshold is being met for whatever reason. So all of this information you can get through Kubernetes dashboard. Through Grafana dashboards. Node exporter, we saw earlier that node exporter is a standard exporter for Prometheus, and this is a standard Grafana dashboard that we are using. Cube state metrics is another exporter, and this is its corresponding dashboard that we can go through. This gives us typical information like cluster CPU usage, pod usage, and just a basic bunch of numbers about what the current state of the cluster is. API server is quite useful, especially if you have multi-node, multi-master setup, and you want to know if any of my API servers were down for a bunch of time. So you can go back in time and then find out if one of those masters were behaving in an odd way. And you have a bunch of other information like API request rate, processing time, if some services, the latency for the API server, how etcd was behaving when it was getting invoked, and so on. So wealth of information here as well. The last one is kubelet. So kubelet runs on every node in Kubernetes, and you can select. So this is a 3-node cluster. You can select whatever node and find out how kubelet was behaving. Again, kubelet crashes are the ones that are most relevant, and you can find out if this had gone down, if there are breaks in between, which means kubelet was crashing for a brief amount of time. Again, you can go back and historically find out how it was behaving over a period of time.
Mayuresh, we've got about 10 minutes left in the session.
Yeah. So that's about Grafana dashboards. We spoke about rules, and when all of this is configured well, how does that look like? So we configure all of this. We have these Prometheus rules. The only thing that was missing was configuring a target for alert manager. So let's say I do it correctly. The rules are getting processed. My alerts are getting generated, and those alerts are, if I configure it to deliver it to my Slack, this is how those alerts look like. So I have a failed mount. I have back off. One of my pods was restarting. The image that I was specified was incorrect. Liveness probe was failing. And this is how all of those errors can be delivered. To close this off, one last thing I wanted to mention was about doing it yourself. So let's say you are doing all of this by yourself. What is it, with all of this understanding, what is it that you need to do? One, you will deploy a Prometheus operator for obvious reasons. It makes our life easier. Create a bunch of Prometheus objects we saw, Prometheus alert manager, Prometheus rules, service monitor. Add correct labels so that all of them get associated with each other. They talk to each other correctly. Once all of that is done, make sure that whatever custom services you want to scrape from, that is happening correctly. Check in the Prometheus UI, native UI. Once you do all of that, all your metrics are in, all your rules are configured properly, deploy Grafana. This can be a standard deployment. Whatever it is, whatever your configuration files for Grafana are, mount them as a config map in the right places. Mount all of your dashboards as config maps so that they don't get lost. And just as I said earlier, not all free dashboards are going to work. This, more often than not, is going to be a slightly painful process. But if you're doing it for, if you're going to use it for a long time, it always makes sense to design your own Grafana dashboards, because then you have the freedom to do it as you like. Once all of this is in place, the last thing to do is configure your alert manager targets so that your targets are getting delivered at the right place. Just a side note, yeah, we can now go into questions if someone has any.
I don't see any current questions. Mayuresh, have you got the config that you use for Slack?
Yes. So this is the alert manager YAML that needs to be by default. What we deploy is a no op. So a bunch of targets are delivered, but they don't go anywhere because the user needs to decide where to deliver them.
Mm-hmm.
This is the alert manager YAML that I've used. Notice I've used Slack config, and this is my webhook and a bunch of other things. And this is the command to actually deploy it. And yeah, alert manager provides a very large number of ways of configuring different receivers. You can configure routes. You might want to deliver different alerts of type warning to one place, alerts of type critical to another place. So a lot of interesting things can be done in the configuration for alert manager.
Yeah, it can gets pretty granular.
Yeah.
For people that are new to there's a question that came in. I'll touch on that. For people that are new to Prometheus, it takes a slightly different approach to alerts as well. They're kind of there until they're resolved. I used to run an APM product when I was at Quest Software. It's a point of contention. Should alert be auto closing or should it have to be manually closed? Prometheus is opinionated. It has to be resolved in the back end to close itself, but you can suppress alarms. A question from Kenneth: what is the underlying time series database? Is it persistent? I'll touch the persistency thing. So with all things Kubernetes, it's only going to be persistent if you provide it a persistent volume claim. In the release that we've got coming out in a couple of weeks, we're going to introduce the ability to provide a storage class. The operator will then use that Kubernetes storage class to provide a persistent volume claim. So therefore it would be persistent. By default, it's not persistent. Mayuresh, do you know what the time series database is, or did they write their own?
Not exactly sure about that. But one more interesting thing I would like to mention here is when you are configuring your own monitoring stack, make sure of recognizing how much space it is going to take. And this is something that it's more of a trial and error, at least for us. So in our case, for example, we had a bunch of scraping targets, and the rate at which we were scraping was very granular. So it was 30 seconds, which was too much. And that was causing the amount of storage that was being used was comparatively higher. So we realized that instead of 30 seconds, if we reduce it to 2 minutes, not much information is lost. And the amount of space that was being consumed was manageable. So you will have to decide the granularity with which you are going to scrape metrics, and the total amount of space that gets consumed depends on the number of things, as I mentioned.
Cool. Any other questions? We have a few moments left before we'll wrap up. As always, these sessions are recorded, posted in our community and Slack. And our Slack is also a great place, or our community site is a great place to reach out and ask any questions around this type of stuff as well. We're here to help make Kubernetes easier for everyone. So the more questions you have, the happier we are. No questions. Mayuresh, I think you did a great job sort of covering the Prometheus 101s. I haven't seen that done for a while. So thank you very much for your time. I understand it's getting quite late for you as well.
Yeah, thanks, Mayuresh.
Okay, thanks everyone.
If you'd like to see us cover a future topic, once again, Slack is a great way to shout out as well.
You're going to, actually, everybody here is going to get a survey at the end of this, and it's just going to ask you 1 to 5 how much you enjoyed this. And then it also is going to give you the opportunity to share ideas for other topics. Please don't be shy. We're very open to it. We'd love to hear ideas. This is for you as much as it is for us. So please share any ideas on topics that you would like to hear more about.
There was one question just came in. Do we have a free tier? Yes, we do. This is my free tier here right now. I'm actually in the process of building and deleting some clusters. If you head to platform9.com/signup, you'll get one of these issued to you instantaneously. All you need is a VM or some cloud infrastructure, and you can get started straight away. So that's there. As long as you have a cluster, we'll keep it running. If you don't have a cluster, it might get put to sleep or suspended. So keep something running, and it will be there forever for free. Yeah, jump in and give it a go. It's completely self-service, and as you can see, this Azure cluster just finished. Grafana was part of that deployment. So everything that Mayuresh touched on is built into the product and included in our free tier as well. This will also work if you have EKS, AKS, or GKE. Just import those clusters, click deploy monitoring, and we'll deploy this monitoring stack into that cluster as well.
Excellent product plug there, Chris. Thank you.
Cool. All right, we're at the top of the hour. If there is nothing else, I guess we'll wrap. Thank you all for your time. Have a great day.
Thanks, everybody. All right. See you all.